In the last video, we showed that out of a group of 100 Asian moms, we would expect 10 of them to have large families. The thing to realize, though, is this isn't always going to be true. That is, even if we're doing a random selection, not every group of 100 Asian moms is going to have exactly 10 of those women having large families. Some might be higher, some might be lower, and so the question is, how different would we expect each group to be? To figure this out, we need to find how much variation we expect, and variation is measured with standard deviation. So what we're actually looking for here is how we calculate standard deviation for binomial probabilities. And the answer is actually really nice. It's extremely different from the standard deviation we've calculated before in that it is straightforward and simple. The formula for standard deviation for binomial probabilities is square root n times p times 1 minus p. Notice that the square root's still there, just like our other standard deviations, but the inside is very simplified. Let's go ahead and calculate the standard deviation for this specific problem. N was 100, P was 0.1, and 1 minus P will be 0.9, 1 minus 0.1. All we have to do then is square root it, and this will give us our standard deviation. Now, for our problem here, our standard deviation is actually going to be right around 3. And what this tells us is that, well, yeah, we expect 10 out of every 100 women to have large families. It might be 3 higher, it might be 3 lower. There's a lot of variation going on here.